Welcome to Frontier Flash. Today we examine the state of artificial general intelligence, often described as AGI, and what recent developments actually signal. Rather than asking whether AGI is imminent, the more useful question is how current systems are evolving, where measurable progress is occurring, and where clear limits remain. First, large-scale foundation models have demonstrated increasingly general capabilities across language, reasoning, coding, and multimodal tasks. These systems are trained on vast datasets using self-supervised learning and reinforcement learning techniques. In benchmark environments, newer models show measurable improvements in problem-solving, long-context reasoning, and tool use compared to earlier generations. However, these gains emerge from scaling model size, training data, and computational resources rather than from a fundamentally new cognitive architecture. What we are seeing is broader generality within a narrow paradigm, not autonomous human-level reasoning. Second, AI systems are increasingly being integrated with external tools and environments. Through techniques such as retrieval augmentation, API access, and structured planning loops, models can query databases, write and execute code, search the web, and interact with software systems. This expands their practical usefulness and gives the appearance of greater autonomy. In controlled evaluations, tool-augmented systems outperform standalone models on complex tasks, yet the intelligence still resides primarily in pattern recognition and probabilistic prediction, not in self-directed understanding. These systems remain dependent on structured scaffolding and human-defined objectives. Third, research into alignment, interpretability, and model evaluation has matured significantly. New methods aim to probe internal representations, measure model uncertainty, and constrain outputs within policy and safety boundaries. There is growing recognition that scaling capability must be matched by scaling oversight. While alignment techniques have improved reliability in many cases, they do not fully eliminate hallucinations, emergent behaviors, or unpredictable failure modes. The technical and governance infrastructure around advanced AI is evolving, but it remains an active research frontier rather than a solved problem. Together, these findings suggest that progress toward more general AI systems is occurring incrementally through scaling, integration, and safety engineering, rather than through a single breakthrough. Capability gains are real and measurable, especially in domains such as coding assistance, content synthesis, and data analysis. At the same time, current systems lack persistent memory, grounded embodiment, long-term agency, and independent goal formation. The trajectory resembles expanding competence within bounded architectures, not the spontaneous emergence of artificial minds. However, caveats are important. Benchmarks do not fully capture real-world robustness. Performance on curated tasks may not translate to open-ended environments. Model behavior can degrade under distribution shift, adversarial prompting, or ambiguous instruction. Additionally, public claims about timelines for AGI often rely on extrapolation rather than empirical certainty. Progress in compute and model scale may continue, but hardware constraints, data limitations, regulatory intervention, and energy costs could shape development pathways. As research matures, the conversation around artificial general intelligence is shifting from speculative inevitability to measurable capability thresholds. Rather than asking when machines will become generally intelligent, researchers increasingly evaluate which cognitive components are reproducible in machine learning systems and which remain elusive. The frontier lies not in dramatic declarations, but in careful measurement of generalization, reasoning, autonomy, and control. Artificial general intelligence, if it emerges, will likely arise from cumulative refinement rather than a single moment of transformation. For now, what exists are increasingly capable systems operating within defined statistical frameworks. The distinction between broad utility and true general intelligence remains meaningful. This has been Frontier Flash. If you value measured analysis of frontier technologies, subscribe for continued briefings on the systems shaping the future.